Okay, so in this setup here, we've got two weights, one hanging over the edge of a table, and then we've got one weight resting on the table, and this weight here is being held, and then it's released. As soon as it's released, obviously then this is going to fall, okay, and it's going to drag that weight along the table, okay, with this pulley sort of supporting the string. Okay, now it's a smooth pulley, right, and the string is inextensible, right, which means it won't stretch, and that means the tension is the same throughout. So when I label the weight here of A, okay, of course then I've got the tension and the string pulling it up, but the tension then that's created in this string is also pulling B, okay. Now we've also got a resistant, a frictional force of 13.2 newtons, we're told, and we're asked then to find the tension and value of A. So what I do, right, I set up two equations, okay, I focus on the forces at A and B, and notice I put my direction of motion this way, right, the acceleration pointing to the direction of motion because it is going this way. Of course then B will be pulled along that way. So using Newton's second law, okay, in the direction of motion, okay, at A, now because it'll be going down, 6G obviously is the heavier weight, okay, and the resultant force is going to be 6G, and of course then the tension is keeping it from falling from gravity, so we take away the tensional force, so that's the overall resultant force there. We've got 6G going down, but the tension in the string pulling it back, okay, and that will equal the mass, which is 6 times the acceleration A. And then at B, okay, at B we've got the tension, okay, take away 13.2, and that will equal the mass times acceleration. Okay, so we've got this here now, right, and we can eliminate things here now in order to get our acceleration and tension. So if I call this 1 and 2, now if I add 1 and 2, okay, if I add 1 and 2, treat them as simultaneous equations, you'll notice that the tensions cancel out, because I've got minus t, add t, they will cancel. Minus t, add t is 0. So I end up having 6G minus 13.2, and then add these, we'll get 8A. Okay, so let's get my calculator. I've left it in my drawer, so bear with me. Okay, now of course 6G is 6 times 9.8, take away 13.2 equals 8A. So 6 times 9.8, take away 13.2, and we get 45.6 equals 8A. And then to get A, we have to do 45.6 divided by 8. So we get our answer, which is 5.7 meters per second squared. Then what we've got to do then, we need to sub this then into 2. Okay, so if we sub that into 2, or into 1, if I sub into 2, we can get the tension straight away. So T, take away 13.2, will equal to 2 times 5.7. Okay, so T then will equal to that there, which is 11.4. Add then the 13.2. And we get our answer to be 24.6 newtons.